So the question here is related to photoelectric effect. We have been given 4 statements, out of which we have to identify the correct one, right? Or the correct one, right? We know that there is a metal surface that has electrons in it, okay? And then some definite amount of energy that we call as work function is required to knock these electrons out of the metal surface. And photons, like energy packets, they fall on the metal surface. Each photon has some energy depending on its frequency, h nu. H is the Planck constant, nu is the frequency. So each photon has its own definite amount of energy, right? And this energy that each photon has should be more than this work function phi to knock the electrons out. Okay, I'll take a simple example to explain, in the context of the options given, right? So first one is the stopping potential depends only on the work function of the metal. What is the stopping potential? Let's say the work function, that is the energy required to knock this electron off, is, let's say, 5 electron volts. I'm just taking an example, okay? And let's say this photon number 1 here has energy of, let's say, 10 electron volt, and the other photon here has energy of, let's say, only 3 electron volts. Okay? This one here is having energy of 3 electron volts only, this one, okay? And this one is having 10 electron volts, right? So that means this photon will be able to knock this electron off from the metal surface because 5 electron volts of energy is consumed to get that electron out of that metal surface, right? Now, what is the stopping potential? Once this electron is out, right, this 10 electron volt photon collided with this electron. Once this electron comes out, it will have energy left that is equal to 10 electron volts, that was of the photon, minus 5 got consumed in the work function. So 5 electron volts of energy this electron will have now after coming out of the surface, right? Now if you apply a potential of V, okay, that can kind of consume this 5 electron volt, right? So the formula we use is the energy that was 5 electron volt left with the electron is Q times the potential, the stopping potential, right? The Q is the charge on the electron, that is not changing, right? So this 5 electron volt is the charge on the electron times the stopping potential, okay? So whatever is the energy left with the electron is equal to the charge on the electron times the stopping potential, right? So this V, is it going to only depend on the work function? No, because this EV has to be equal to the left out energy. And the left out energy with the electron depends on 2 things. The work function, of course, and the energy of the photon, incoming photon. And another photon of 7 electron volt collided with this electron. The energy left with the electron would be 2 electron volts only. In that case, the stopping potential will be different, right? 2 electron is equal to the charge on the electron times the stopping potential. So V in this case will be different than in this case. So certainly the stopping potential is not only dependent on the work function that is getting consumed, that is getting used up in getting that electron out, but what was the energy of the photon that collided with the electron, right? That will decide how much is the energy left with the electron after the collision, right? So certainly this is not correct. It is not only dependent on that, okay? The second statement is saying that the saturation current increases as the intensity of the incident light increases, right? Now the current is Q upon T. The basic formula is this, right? So this current is dependent on this Q, like how many electrons are coming out, right? So how many electrons will come out will depend on how many photons are colliding, right? And the number of photons colliding is dependent on the intensity of the incident light, right? So certainly this is correct, right? Intensity is how many photons are falling per unit area per unit time, okay? If the intensity is more number of photons are colliding, that means the probability of the electrons coming out are more. If more electrons are coming out, that means this charge Q is going to be more and the saturation current is going to be more. So this is correct, right? The maximum kinetic energy of a photoelectron depends on the intensity of the incident light. No, that is not correct, right? The maximum is dependent on what is the photon with the maximum energy, okay? No matter how many 7 electron volt photon are falling, the electron that will come out will have only this 2 electron volt energy because only one photon is colliding with one electron at a time, okay? If this 3 electron volt photon will collide with the electron, it won't be able to knock out the electron. So certainly this is not correct. The maximum kinetic energy of a photoelectron depends on the intensity of the incident light. This is not correct. Okay, it will be dependent on what was the energy of the photon with the maximum energy. Okay, corresponding to that, we'll have an electron that has come out with the maximum energy left out with it, right? So obviously option number C here is not correct. Now coming to point D, photoelectric effect can be explained using wave theory of light. No, this is particle nature of light. We are seeing that one photon is colliding with one electron at a time. Okay, otherwise all this thing is going to be wrong, because only one photon is colliding with an electron at a time. Okay, had the explanation been based on wave theory, so there was a possibility that two waves will come and hit one electron simultaneously. So in that case, everything that we talked here will not be true. Yes, this discussion is true only if we treat light as small particles of energy. Okay, energy packets called photons. If we were assuming the light to be wave, there was a possibility that two waves are coming and hitting an electron at the same time. In that case, we can't say that the maximum kinetic energy of the photoelectron is going to be dependent on the photon having the maximum energy, because more than one wave can hit the electron at the same time. So the whole discussion that we did here goes wrong. So certainly we are assuming the light to be particles, the photon. So this D option is also not correct. So we are only left with option number B here, right? So that is option 3. So option number 3 here becomes our answer. Okay, thank you.